Hello, my name is Joseph Burse, and this is my presentation for my final project for ISE 739, Optimization in Aerospace Systems. The purpose of this presentation is to take the concepts learned in class and apply them toward the human body. The goal is to relate cost to specific amounts of protein, fat, and carbs consumed. The objective being to minimize cost associated with maintaining a healthy lifestyle. The analysis of our system will use the design structure matrix, the global sensitivity equation method, and the multidisciplinary feasible framework to optimize and interpret our system. First, the design structure matrix, or DSM, is shown. The object on the right depicts the final iteration of the DSM, exhibiting the interactions between the subsystem. The consumption subsystem consists of equations that determine the amounts in grams of protein, fat, and carbs consumed. Next, the exercise subsystems compute how many calories are burned depending on the individual's weight and what activities he or she performs on a daily basis. Both the consumption subsystem and the exercise subsystem feed into the caloric intake and burn subsystem. This subsystem calculates the total caloric intake as well as total caloric burn from the entire subsystem, or from the entire system. Lastly, the digestion and metabolism subsystem computes the calories that are burned based on the thermic effect of food as well as our body's metabolism. After laying the framework with DSM, we put in a set of inputs and converge the system for an individual desiring to maintain their weight and another desiring to gain weight and build muscle. This is contrasted in the image to the left, exhibiting an approximate $20 daily difference in the amount of money spent on food. For the purpose of our GSE, our analysis assumes the individual desires to maintain their weight. The total derivatives calculated by our GSE appear to suggest that the system is not very sensitive to changes in the inputs. Lastly, the multidisciplinary feasible method is implemented. This method appears to minimize cost to $7.07. However, the amount of fat and carbs consumed appear significantly low. In conclusion, it would appear that refining the interactions between subsystems is necessary to create a more reliable analysis. Further development of the models used for various parts of the system could use work as well. Increasing the data for average cost per gram of high protein fat or a carb item, and analyzing calorie burning activities to be more precise are two suggestions for further development.